All right, so what we have here is a homogeneous linear system. And what that means is we have a system of linear equations, but where the solution vector is all zeros. And so what we're looking for is um, to find all of the possible solutions to this system of equations. Those solutions form a subspace of, in this case, R4, and we want to identify a basis for the solution space. So first things first, what we need to do is to solve this system. And so let's write out our augmented matrix. We have 1, 0, 0, 1, 0, minus 3, 0, minus 3, 1, 5, 4, 3, and lastly, minus 2, minus 12, minus 8, and of course that's all equal to 0. And so, as I solve this system, what I need to do is to identify the uh, the reduced row echelon matrix. So let's enter in our rows. First row, second row, third row, comma 0, and our last row is going to be 1, minus 3, 3, minus 8, 0. I want to evaluate that. I end up with the reduced row echelon form is 1, minus 3, 0, minus 2, 0, 0, 0, 1, minus 2, 0, and then 2, 0 rows. Alright, so this is our reduced row echelon form. So we once again notice that as we did earlier in the course, that these two are pivots. Alright, and then let's associate this variable with A and this variable with B. And so what we're saying here then is that x2 and x4 are equal to A and B. Right? We are dealing with these two variables specifically because those are the free variables, right? Now, for the pivots, with x1, what I know is that x1, if I solve this, has to be equal to 3a plus 2b, and that x3 has to be 2b, right? And the reason I know this, let me work one of these out. This first equation tells me x1 minus 3x2 minus 2x4 is 0. So x1 must be 3x squared plus 2x4, and we've already decided that those were A and B. And x3 follows in the same way. So what we have as a solution space then must be the set of all vectors 3a plus 2b, a 2b, b, such that A and B are real numbers. Right? So for every choice of A and B, because A and B can be whatever they want, the vector that we generate here, that's going to be a solution to the system of equations. Now, what I want to know is what are the bases for this what's the basis for these solutions? And what we see is that, hey, this vector 3a plus 2b, a, 2b, b, I can rewrite that as a times 3, 1, 0, 0 plus b times 1, 0, 2, 1. Right? If I take those two vectors and if I multiply the a's and the b's into these vectors and add them together, I'll end up with exactly 3a plus 2b, a, 2b, b. And as a result of that, what I have is that, oh, every single thing in the solution space is written as a linear combination of these two vectors. And more importantly, it's pretty clear that none of these vectors are a linear combination of the other, because there are zeros in these coordinates, there are no zeros in those coordinates, and same here. It's clear that one of them is not the multiple of the other. So they're definitely pointing in different directions in the space, so they're linear independent. So a basis for the solution space is these two vectors we just found, 3, 1, 0, 0, 1, 0, 2, 1. All right, and that concludes Module V for this course. Thank you very much. See you in the next video.